Hi, my name is Diedrich, and I'd like to spend the next several minutes talking about something that I've fielded a lot of questions about recently in my professional role. So, I am working for a company that's considering implementing Databricks as the technology of choice for our next generation data and analytics platform. And one of the things that I find I'm often guilty of is jumping right ahead to how do you use this thing without taking the time to really explain it to a general audience. So let's take a moment to step way back and really look at what Databricks is, because I think even Databricks itself has a tough time getting over the marketing language and explaining to a general audience who uses it, why, and to do what. Databricks is a set of tools that allows users to manage and analyze data sitting on a cloud data platform more efficiently. Now, think of it like the same way that the Google search bar should have evolved into something that looks like ChatGPT if Google were still innovative. Databricks is what the Microsofts and the Oracles of the world should have looked like by now if they didn't spend the last 20 years resting on their laurels. And speaking of innovation at Google, good job on the quantum computing, but over here at YouTube, you still want users to like and subscribe? What is this, 2004? You can do better. So now you've got the short answer. But if you want a little bit more context, then we're going to have to go back in time about 15 years. So let's say we're in 2010. So cloud computing is suddenly a thing. Early movers in this space were companies like Rackspace, but the latest innovators were AWS, IBM came along in 2005, 2006, Azure just hit the scene. And now companies are asking themselves, is now the right time to consider making the move to the cloud? So why was the cloud such a big deal to begin with? The answer really comes down to how do people use computers. So an individual only needs the infrastructure, typically, of the machine that's at their fingertips. But companies rely on sharing data between lots of different individuals. Companies also accumulate a lot more data than individuals do. And so they need a place to store all of this information, and they need the processing power that comes from being able to share it. So now keep in mind, we're already in 2010, so we're well into the age of big data. And in order to handle this amount of data, companies typically run their own data centers. And that's a significant investment. I mean, to run a data center, what do you need? You need a place to house all of this physical equipment, generally a warehouse. Kind of makes the term data warehouse kind of apropos, doesn't it? You need lots of power, and not just to run the machines, but also to cool them. Computers generate a lot of heat. And then you need backup in case the lights go out. You need redundancy in case data gets corrupted. You need backups. For all of these what-if scenarios, the actual amount of infrastructure you need to contain your data multiplies. And then beyond that, you need skilled individuals who can replace drives when they go bad, who can upgrade servers, who can keep the rats and squirrels out of the break room. I mean, all of the things that go with running a big, expensive physical operation. And that was really the value proposition of the early cloud days, is that we will consolidate all of this infrastructure, and then we'll sell capacity to our customers, typically companies, who need to use it. Now, in order to make this practical, the cloud providers needed to use software to create what's called virtualization, which allows the companies or their clients to use their data within the same physical space, but keep it separate. And a lot of companies required some time to feel like they really trusted the security of the cloud to keep that safe. And that required both the amount of time necessary to see that there was a track record, and also the internalization of the core reality, which is that the cloud providers could build the talent necessary to keep that data secure in a way that most individual companies really couldn't competently compete with. And so here we are today. The cloud seems like a no-brainer. It is way cheaper than running your own data center. It's faster to set up. It's more performant. It is infinitely scalable. It's redundant across geography so that it's theoretically impervious to almost anything short of the apocalypse. It's a good idea. In fact, it's one of those ideas that is so obvious that it makes you wonder why it wasn't obvious to everyone a long time ago. So now you have a place to put your data, and that's great, but you need to organize it. Your workers need an efficient way of being able to organize information so that they know where to look, so that they don't have access to information that they shouldn't, so that they're able to manipulate that data efficiently and add data to it through their own work, as well as be able to share it amongst themselves. So this is what databases have traditionally been for. And database technology has been around since long before cloud computing. But what makes it different is that databases were typically what's called relational. And in order for relational databases to be performant, they needed to be structured within certain size constraints. So, enter the cloud and infinite scalability. George Carlin had this skit called A Place for My Stuff, where, to cut to the chase, he basically boiled it down to the idea that stuff grows to fill the size of its container. And so it is with practically infinite scalability. And so what you saw companies starting to do was accumulate more information, and not just that, but they wanted to include information of different types. If you want to go down the rabbit hole on this, I encourage you to look up the V's of big data. So as both the quantity and the variety of data started to increase, companies needed new tools to figure out how to work with it. The cost to store data became so cheap that for many organizations, it seemed like the price of having data that you didn't need was much lower than the potential needing data that you don't have. And so if structured data was traditionally stored in something called warehouses, the term that the industry adopted for this new storage medium of data of all types was a data lake. This is another area where it would be really easy to go down a rabbit hole. But we'll just say at this point that not all organizations that ran data lakes were equally proficient at managing their data. And so to the extent that unused information became difficult to find and a little bit muddled, you often heard the term data swamp thrown around. But leaving the management question aside, there was also a problem that data lakes weren't always as performant as relational data warehouses. And some of this has to do with the fact that data lakes typically stored data as files rather than as tables, which had pluses and minuses. And then finally, there's the administration of tools used to interact with the data and manage the data itself. If things weren't already starting to get complicated, this is where they truly went off the rails. And to put it bluntly, the tools that the cloud platform providers used to manage data assets were chock full of functionality, but often lacking in terms of usability. In fact, an entire industry started to spring up in the late 2010s to make the process of administering a cloud platform a little bit more manageable. So here comes this project out of UC Berkeley, where they're working on this analytics engine called Apache Spark. And what they did is pretty brilliant. They figured out a way to structure information that took advantage of the strengths of both relational data warehouses and data lakes. And then they found a way to organize that information that avoided many of those pitfalls. It was, in fact, such a good idea that they decided to make a company out of it. And that company now holds one of the larger conferences in San Francisco. Think of it this way. In much the same way that AWS and Azure commoditized physical data centers, Databricks is commoditizing AWS and Azure. It doesn't replace the cloud providers, but it rather sits on top of them and adds value by providing an integrated environment where users can interact with information in an intelligible and predictable way. but they can share information in a structured fashion. It also integrates several cutting-edge tools like artificial intelligence, machine learning, large language models, provides sandbox workspaces. It's not a shop of wonders that does all things, but it solves many of the problems that organizations were previously facing trying to manage data that they already owned and were storing on the cloud. I will say this. I'm still early in my journey learning how to architect, productionalize, and administer Databricks on an enterprise level. And so as I learn more, I'm likely going to have a lot more to say here. So stay tuned or, subscribe. Still looking at you, Google. Thanks for joining me.